Halogen and halides. So this is about the chemistry of chlorine, fluorine, bromine and iodine. There's also astatine, but we don't talk about that because there's not a lot of it around in the universe. So the four main halogens: fluorine, which is F2, chlorine, Cl2, bromine, which is Br2, and iodine, which is I2. So at room temperature, fluorine is a very pale green gas, chlorine is a yellow-green gas, bromine is an orange-brown liquid with a very low boiling point, and iodine is a silver-purple shiny solid. All the halogens are diatomic, which means that fluorine is present naturally as F2, chlorine is Cl2, iodine is I2, bromine is Br2. So if we look at fluorine, for example, we know that it's got 9 electrons and 9 protons, and the electrons are arranged 2 in the first shell and 1, 2, 3, 4, 5, 6, 7 in the outside shell. And that makes sense because fluorine is in group 7, so you'd expect it to have 7 electrons in its outer shell. So if you take our atom of fluorine and we show the outer electrons only, if it comes into contact with another atom of fluorine, which it almost certainly will because it's very hard to get a single atom of fluorine by itself without anything else around, it forms a covalent bond. Remember, a covalent bond is a shared pair of electrons with the adjacent fluorine and makes F2. It does this so that each fluorine has a share of 8 electrons. So the fluorine on the right hand side has a share of 1, 2, 3, 4, 5, 6, 7, 8 electrons. And the fluorine on the left hand side has 1, 2, 3, 4, 5, 6, 7, 8 electrons. If you could get a microscope and you could get a balloon full of fluorine, which wouldn't be a great idea, and you looked inside, you'd see all of the fluorines are paired with another fluorine. This is what diatomic means. It means there are 2 atoms in the molecule. So fluorine goes around as F2. In fact, because all of the halogens are in group 7, and because they've all got 7 electrons in their outer shell, and because they all want to have 8 electrons in the outer shell, and they want to gain or share 1 electron, all of the halogens go around in pairs. So it's always F2, Cl2, Br2, I2. And if you show the outer electrons only, the dot cross diagrams for the elements are all the same because they've all got a single covalent bond, a single shared pair of electrons between each of the 2 atoms. So iodine has got a full outer shell in I2 because it's got 1, 2, 3, 4, 5, 6, 7, 8. And the iodine on the right hand side also has 1, 2, 3, 4, 5, 6, 7, 8. And the same for bromine, chlorine and fluorine. So when a halogen gains an electron, such as when it reacts with sodium, forms an ionic compound. Remember, an ionic compound is when a metal reacts with a non-metal, it becomes a halide. So fluorine, when it gains an electron and becomes F-, becomes fluoride. So here's the example. If we take sodium, this thing here, 2 electrons, 8 electrons, 1 electron, and reacts with a fluorine atom, which has got 2 electrons and then 7 electrons, 1, 2, 3, 4, 5, 6, 7. To get a full outer shell, the sodium gives this electron away to the fluorine. The sodium becomes positive because it's lost a negative electron. Remember, we show that the sodium is positive by the plus sign there. The fluorine becomes negatively charged. We show that with a negative sign. And the whole compound is called sodium fluoride. Notice the D. So fluorine, when it gains an electron and becomes negative, becomes fluoride. If you do this reaction and you show it this way and you only show the outer electrons, so we're only showing the outermost electron of sodium and we're only showing the outermost 7 electrons of fluorine, then you find that sodium has an empty outer shell. It's still positive because it's given away the electron. And fluorine still has the 1, 2, 3, 4, 5, 6, 7, 8 electrons. And what we're not doing is showing the inner electrons of sodium and the inner electrons of fluorine. So if you take a lump of sodium and you react it with fluorine gas, you'll end up with sodium fluoride, which is a white compound, and it forms this lattice structure with alternating fluoride and sodium ions. Now, if you go and you only show the outermost electrons of sodium and the outermost electrons of chlorine or bromine or iodine, you'll find that the reaction you get when you write it down is identical, because all of the elements in group 7 have only got 7 electrons in their outer shell. So when chlorine takes an electron from sodium and becomes chloride, it's got 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. It's got some inner electrons as well, but if we're just showing the outer shell electrons, we don't need to show those. And it's chloride because it's got 8 electrons in its outer shell and it's got a negative charge. When bromine gains an electron, it becomes bromide. It has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell. It's negatively charged. Again, it also has inner electrons that we're not showing, but if we're just showing outer electrons, it's very similar to chloride. Same with iodine. So iodine starts with 7 electrons in its outer shell. If it gains an electron from somewhere, such as if it reacts with sodium, it then has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outer shell as well. It's negatively charged. So iodine goes to iodide.